Good morning and welcome to a video on calculating exact trig values. Now in this video we're going to look at calculating the exact values of the sine, the cosine and the tangent of 30 degrees, 45 degrees and 60 degrees. In the future we'll look at calculating 0 degrees and 90 degrees, but for just today we're going to look at these ones in the box here. Okay. Now before we actually look at calculating these values, what does it mean to take the sine of 30 degrees? What does this actually mean? Okay, now in order to work out what the sine of an angle means, we just need to think back to our SOHCAHTOA definition of trig functions. So SOHCAHTOA, okay, and we know that the sine of an angle is equal to the opposite side divided by the hypotenuse. So it's the opposite divided by the hypotenuse. Okay, and I've got a right angle triangle here with a 30 degree angle and a 60 degree angle. Now the opposite side, so the opposite of the 30 degree side is going to be this length here. So if I just highlight that there, so that is our opposite side, and our hypotenuse is always the one opposite the right angle, which is this length here. So the sine of 30 degrees is this length divided by that length there, and you might already see approximately what that is, how many times bigger this is compared to that. Okay, and I've just put up another right angle triangle here with the same angles, so these are similar triangles. Okay, and again the sine of 30 degrees is going to be this length divided by this length here. Okay, and it doesn't matter how big these lengths are, the sine of 30 degrees is always going to be the same. So this length divided by that length is the same as that length divided by that length. Okay, now we're going to look at actually calculating these values. So I've got down here, I've got a, this is an equilateral triangle, and because it's an equilateral triangle that means that each of these angles is 60 degrees. So 60 degrees, 60 degrees and 60 degrees. Now just a moment ago I said it doesn't matter what these lengths are, okay, because the sine of an angle is always going to be the same no matter what the lengths are. So just for ease of use I'm going to say that that is going to be 2. So these are all length 2. I could have used 1, I could have used 50, I could have used 100, but just using 2 it makes the maths a bit easier. Now how do I construct a 30 degree angle from this equilateral triangle? Now the easiest way I can think of doing that is if I just drop a perpendicular line down like that, okay, and because it's perpendicular it means that this angle here is a right angle, and this angle, because it's perpendicular, it bisects the 30 degree angle, so now that is a bisects the 60 degree angle, so now we've got a 30 degree angle here. And in terms of the lengths, this was length 2, and because this perpendicular line bisects this line here, this length is now 1. And now the only one we've got to find out is the height of our triangle. And how do we work out the height of a right angle triangle if we've got two lengths? Well, we can use Pythagoras Theorem, and Pythagoras Theorem tells us that c squared equals a squared plus b squared. So the length of the hypotenuse squared is equal to the lengths of each of the shorter sides squared. Now we know what the hypotenuse is. We know that the hypotenuse is 2. We want to calculate one of the shorter sides. So if we call that a, if we rearrange this, we've got a squared equals c squared minus b squared. Okay, c squared, well c is 2, so c squared is 4. And b is 1, so b squared is also 1. Therefore a squared equals 4 minus 1, which is 3. So a equals the square root of 3. So a is the square root of 3. And now we've got all of the different lengths and all of the angles. We can calculate all of these values here. Okay, let's start off with the sine of 30 degrees. Okay, and I'm going to write the SOHCAHTOA definition up here to help me. So I always do this in case I forget. So SOHCAHTOA, we know that the sine of an angle is opposite over hypotenuse. So from our 30 degree angle, the opposite side is 1, and the hypotenuse is 2. So the sine of 30 degrees is 1 over 2, or we can just say a half. Now let's have a look at the sine of 60 degrees. So the sine of 60 degrees, this time we're going from the 60 degree angle here. So opposite is root 3, and the hypotenuse is 2. So the sine of 60 degrees is root 3 over 2. Now if you want to pause the video and have a go at these ones here, you can. Okay, I'm assuming you've paused the video now, so let's move on to the cosine of 30 degrees. So the cosine of 30 degrees, so from the point of view of the 30 degree angle, we know that cosine is adjacent over hypotenuse, so the adjacent is root 3, and the hypotenuse again is 2, so it's root 3 over 2, and you may have spotted something. We've got root 3 over 2 here and root 3 over 2 here, so you might want to think about why that's the case. And now if we look at the cosine of 60 degrees, so this time from the 60 degree angle, cosine is adjacent, which is 1, over hypotenuse, which is 2. So 1 over 2, which is a half. And again, we can hopefully see a pattern here. Okay. Now finally, let's move on to the tangent. So the tangent of 30 degrees. So from our 30 degree angle here, the tangent is opposite over adjacent. So our opposite is 1, and our adjacent is root 3. So it's 1 over root 3. Now you can leave it like this, but recently you've learned how to rationalise denominators. So I'm going to rationalise this denominator. So to rationalise it, I just multiply by root 3 over root 3. 1 times root 3 is root 3, and root 3 times root 3 is just 3. So a tan of 30 degrees is root 3 over 3. If you did put 1 over root 3, that's not wrong, but it's much nicer in this form. Okay, and you'll see why later. Okay, and then finally, tangent of 60 degrees. So from our 60 degree angle, tan is opposite over adjacent. So opposite is root 3, and adjacent is 1. So root 3 over 1 is just root 3. Okay, in the next video, we're just going to cover the sine, the cosine, and the tangent of 45 degrees. Okay, so we've looked at 30 degrees and 60 degrees in this video. So I hope you enjoyed that, and I'll see you in the next video.